Okay, let's talk about inverse functions. So if f of x is 2x plus 3, f of 2 would be 2 times 2, 4 plus 3, 7. F of 3 would be 6 plus 3, 9. F of 4 would be 8 plus 3, 11. If I asked for what x will I get 2, I would have to do something like 2x plus 3, and I want it to come out to be 2. So I subtract 3 and I get 2x equal negative 1. Divide by 2 and I get x equal negative 1 half. So x would be negative 1 half. If I put negative 1 half in here, I get 2 times negative 1 half. Negative 1 plus 3 is 2. So what I did here was I kind of reversed the process. I put in 2, got 7, but here I wanted to know what to put in to get 2, and it was negative 1 half. So what if I were given a whole bunch of these and had to do them backwards? Could I create a function called the inverse function of x, which the inputs could be 7, 9, 11, and 2, and I'd get 2, 3, 4, and negative a half out of it? Well, the way you find the formula for that, I might be able to guess here, like this says multiply by 2 and subtract 3. If I reverse that process, the last thing I did was add 3, so I would go minus 3. And before that, I multiply by 2, so I have to probably divide by 2. Let's see if that works. 2 times, putting 2 in here, minus 3 is minus 1. Divide by 2 is negative a half. Put 7. 7 minus 3 is 4, divided by 2 is 2. 9 minus 3 is 6, divided by 2 is 3. So it's working. But the way to get that, take your original function and change the function name to y. So it would be y equals 2x plus 3. Now we're switching the roles. This was our x, this was our y. We want to change it so this is the x and that's the y. So we're going to swap y's and x's. Every place there's a y, we're going to make it be an x, and every place there's an x, we're going to make it be y. And then we're going to solve for y. So to get this by itself, I would subtract 3 from both sides. And then I would divide both sides by 2. Which was the inverse function that we figured out. So let's do the inverse on this. Change the function name to y. Swap the y's and x's, so the y becomes an x, and the x's become y's. Both x's become y's, and the y becomes an x. And solve for y. This gets a little tricky here for some people, so I'm going to work this through. I'm going to multiply by y on both sides, and I get xy equals y plus 2. Now, if I've got y in 2 different places and I want to solve it, like if we had, for example, 3x equals 2x minus 1, we'd get all the x's on one side. We'd get all the y's on the same side. Subtract y from both sides. And we get xy minus y equals 2. Now, if I did that here, I'd go minus 2x minus 2x, and you would say 1x, but I'm going to write it's 3x minus 2x equals minus 1. Then I would factor out an x and get x times 3 minus 2, which is 1. That's how we get to the 1x. Well, here we're going to do it. It's not going to be as easy, but we're going to factor out the y. And y times x makes xy. And y times -1 will make a negative y. And then to solve for y, that's times this. So I'm going to divide by x minus 1. And I get y equals 2 over x minus 1, which should be the inverse of this function. Let's check. If I put in, let's say, 4. 4 plus 2 is 6 divided by 4. 4 goes to 6 divided by 4, or 3 over 2, or 1 1/2. So, if this is the inverse, I should be able to put in 1 1/2 in here. 1 1/2 minus 1 is a half. Half into 2 goes 4 times, and I get back to my 4. So this is the inverse. Whatever this does to x's, this takes it back. That's what an inverse function does. Now, it's unfortunate they use -1 for the notation, because something like 3 to the -1 means the reciprocal, 1 over 3. This does not mean 1 over the original function. It means the inverse of it. Okay? There is a reasoning there, but I'm not going to bother with it right now. All right. So what's the inverse of this function? Well, there's only 6 points in this. 3 goes to 4, 2 goes to 2, 1 goes to 0, and so on. So the inverse would take the outputs of this one, which were 4, 2, 0, 1, 3, 5, and take it back to the original inputs. So 4 would go back to a 3, 2 would stay a 2, 0 would go back to a 1, and 1 would go to 0, and 3 would go to -1, and 5 would go to -2. And this is a picture of the inverse. Now, if this had had maybe 2 going to 2 and 0 going to 2, it wouldn't have been 1 to 1, and therefore the inverse would have been 2 going to 0, and I would have had 2 inputs giving different outputs, and it wouldn't have been a function. So I would have said it doesn't have an inverse function. It has an inverse, but it's not a function because it would have 2 inputs giving the same output. But this one was 1 to 1, and so I can do the inverse. Now this one. So let's go through the steps. First, change the function name to y. Let's then swap the y's and x's. And then solve for y. And if this was a minus, we'd have to get rid of the minus, but it's plus, so we don't have to worry about it. Get rid of the cube root, which we can do by cubing both sides. And that gets rid of the cube root, and we get y minus 2 equals x minus 3 cubed. Add 2 to both sides. And that should be the inverse. So k inverse of x looks like it's 2 plus x minus 3 cubed. Oop, some of that it didn't show. So subtract 3, cube both sides, and then add 2. Let's check it. See, what's an easy number to get the cube root of? I know the cube root of 8 is 2. So if I put in 10 for x, 10 minus 2 is 8. Cube root of 8 is 2 plus 3 is 5. So 10 goes to 5. So I should be able to put 5 in here and get back to 10. 5 minus 3 is 2. 2 cubed is 8. 8 plus 2 is 10. So 1 point checking doesn't prove that it's an inverse, but it's a pretty good indication that this is correct. Okay. Now this one's a little bit trickier. So let's go through the steps. Let the function name be y. Swap y's and x's. Solve for y. So I'll subtract 4 from both sides. So I got x minus 4 equals negative y squared. To get rid of the negative, I have to do that first. I multiply by -1 or divide by -1 on both sides. And I get negative x plus 4 equals y squared. Take the square root, and I get y, but I run into a problem, because when you take the square root, it's plus or minus. Excuse me. Boy. Sorry. Okay. I'm getting 2 answers. Why is that? What's this look like? A parabola, upside down, and up 4. 1, 2, 3, 4. Well, it is a function, past the vertical line test, but its inverse, y, this was 0, 4, and 0, 4 would go to 4, 0. So this point goes to here. This point was 2, 0. Its inverse would go to 0, 2. They're switching order. It went through 1, 3. So its inverse would go through 3, 1. And -1, 3 would go to 3, -1. Do you see how this is not becoming a function? It's going like this, and this was -2, 0 will go to 0, -2. So you can see this point went over to here. This point went over to here. So they go across, this one went across, this point went up here, this point went down there, this point went down there, and this point went up there. And hopefully you're seeing that there's kind of this line of reflection. Y equal x. And why is that important to the inverse? Well, on that line is 0, 0. And if you do the inverse, it's still 0, 0. On that line is 1, 1. If you do the inverse, it's still 1, 1. Now on the line is 2, 2. Inverse is still on there. Every point on here in the inverse stays. Everything else, anything up here, above that line, goes to below that line. Anything below that line goes to above that line. So this is the line that is fixed when you're doing inverses. But the problem was, this is not a function. Now, if we had restricted the original one to maybe only being for x's 0 or bigger, just that part, which is we could make that be the domain of my original function. Let's say the domain was from 0 to infinity. Then when I swap it, that becomes the domain becomes the range for this. And it would become from 0 to infinity, the range on this. And the range of the original, which was from negative infinity up to 4, this was the domain. The range is from negative infinity up to 4. On the inverse, with this restricted domain, the new domain would be from negative infinity to 4. I can use anything from negative infinity to 4 in this function, and I won't get these negative answers. I'll get these as a range. So the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. They swap roles, okay? And we're switching to y and x's. And the only place that doesn't switch is at y equal x. That becomes important to seeing what the inverse looks like. And that's my presentation on inverses.